Welcome to this explainer. Today, we're breaking down the foundational Preliminaries chapter of Wes McKinney's authoritative guide on Python data analysis. Look, if you're aiming to become a highly effective data analyst and build your own data workbench completely from scratch, you are in the exact right place. We're going to cover the absolute essentials to get you set up and totally ready to wrangle some real-world data. Let's get into it.
Okay, so let's anchor ourselves to the source material. We are looking at the definitive handbook for data wrangling, the third edition of Python for Data Analysis by Wes McKinney. And why does that matter? Well, he's the actual creator of the pandas library, so we're essentially getting our blueprints straight from the architect himself. This specific edition is totally updated for Python 3.10 and pandas 1.4, which means we're working with modern, up-to-date standards. Here's our roadmap for this explainer. We've got 1. The data analysis landscape. 2. Why choose Python? 3. The essential Python toolkit. 4. Setup and installation. And finally, 5. Community and navigation.
Section 1. The data analysis landscape. Before we start building anything, we really need to look at those blueprints and figure out exactly what kind of raw material we're dealing with.
You know, it's really easy to throw around broad buzzwords like data analysis or data science or even data munging. But we need to ask what that actually looks like in the real world on a daily basis. When we say we're analyzing structured data, what does that deliberately vague term actually mean?
Well, structured data isn't just one single thing. It encompasses a few common forms. We've got tabular or spreadsheet-like data, where each column might be a completely different type, like strings or dates. Think of what you'd pull from a SQL database or a standard CSV file. We also have multi-dimensional arrays, matrices. Then there are multiple tables interconnected by key columns, much like primary and foreign keys in relational databases. And finally, time series data, which can be evenly or unevenly spaced. Honestly, if you've ever spent time in Microsoft Excel, a lot of this raw material is going to feel super familiar to you already.
Moving on to Section 2, Why Choose Python? With our materials defined, let's examine why this language is the undisputed champion for this kind of work. So here is the crucial point. Python elegantly solves what organizations historically called the two-language problem. Back in the day, it was incredibly common to research and test out new ideas using a specialized language like R or SAS. But when it came time to actually deploy those ideas into a large-scale production system, the software engineers would have to completely rewrite the whole thing in Java, C# or C++. Python solves this beautifully. It's an incredible environment for both the initial prototyping and the final production system. You just don't need to maintain two development environments when one will do the job. And that brings massive organizational benefits by putting your researchers and your engineers on the exact same page. And this brings us to Python's secret weapon. It acts as a glue. See, in scientific computing, you spend a huge amount of time using legacy Fortran and C libraries for the real heavy lifting, stuff like linear algebra or optimization. Python easily glues together decades worth of this legacy software. You can write your high-level logic in Python, and the moment you hit a computational bottleneck, you just pass that specific chunk of work down to lower-level, highly optimized C code. It literally gives you the best of both worlds. Now, to be perfectly objective here, Python isn't flawless. It's an interpreted language, so naturally it runs slower than compiled C++. And as this quote highlights, Python can be pretty challenging for highly concurrent, multi-threaded applications. Why? Because of the Global Interpreter Lock, or the GIL. The GIL essentially prevents the interpreter from executing more than one Python instruction at a single time. So if you're building some ultra-low latency, high-frequency trading system where literally every microsecond counts, Python might not be your best bet. But for the vast majority of data applications where programmer time is actually way more valuable than CPU time, Python is the clear winner. Section 3, the Essential Python Toolkit. Now that we know why we're using this language, let's open up the toolbox and inspect the essentials you'll be using every single day. This ecosystem maps out really cleanly. Each library serves a highly specialized vital purpose. NumPy is basically the cornerstone. It handles fast, multi-dimensional arrays and acts as the lingua franca for exchanging data between algorithms. Then we have pandas, which takes NumPy's array computing and adapts it perfectly for tabular, heterogeneous data. When it comes to visualization, Matplotlib is the most popular tool out there for drawing publication-ready 2D plots. And as you move into modeling, scikit-learn is your go-to for machine learning and prediction, while stats models is tailored much more for statistical inference and p-values. Looking a bit closer at pandas, its origin story is actually fascinating. It was born out of a real-world finance need back in 2008. Wes McKinney was working at AQR Capital Management, and he desperately needed a tool that could blend the fast array computing ideas of NumPy with the data manipulation capabilities of SQL and spreadsheets. He specifically needed something highly capable of handling time-indexed business and financial data, all in one place. That real-world frustration is what led to pandas, which, fun fact, is actually a play on the economics term panel data.
So how does all this translate into our coding environment? Well, unlike traditional languages that force you into this really rigid edit, compile, run loop, Python's data ecosystem completely revolves around IPython and Jupyter notebooks. The IPython project started way back in 2001 to make a better interactive interpreter, and it eventually evolved into the browser-based Jupyter project we know today. This ecosystem encourages an execute and explore workflow, and that is absolutely critical, because data analysis is fundamentally exploratory. It's built on trial, error, rapid iteration, and debugging on the fly.
Section 4. Setup and installation. We have our blueprints, we have our tools, so let's move to the practical side and get your personal workbench ready to go. Getting started is a surprisingly straightforward checklist. First up, install Miniconda for your specific operating system, Windows, Linux, macOS, whatever you're running. Miniconda is highly recommended because it manages your Python environments without all the unnecessary bloat. Next, you just pull down your necessary packages using the Conda or pip package managers. And finally, choose your workspace. You can spin up a Jupyter notebook directly or use an IDE like VS Code, which actually has absolutely excellent built-in Python support today.
And as you gear up to practice these concepts, keep in mind that you don't have to go hunting for raw material. All the data files and datasets you need to learn these techniques, whether that's financial data or baby names, they're all freely available to clone directly from the author's GitHub repository. Just a quick heads up, if you download it as a zip file, remember to fully extract the contents to a directory on your machine before you try running the code.
Section 5. Community and navigation. Finally, let's talk about the support system around you, because you are definitely not learning in a vacuum. Outside of a simple internet search, you can tap into a massive, incredibly vibrant community. I mean, there are over 2,500 contributors to pandas alone. When you need help or just some inspiration, there are active mailing lists like the PyData Google group for panda-specific questions. And then there are the global conferences, PyCon for general Python, SciPy for scientific computing, and PyData, which hosts regional conferences all over the world specifically targeted at data analysis use cases. So there we have it. Now that you understand the data landscape, the historical shift to Python, the essential libraries, and exactly how to set up your environment, your foundational preliminaries are mastered. The only real question left to answer is, what real-world problem are you going to solve first? Thanks for joining me on this explainer, and happy wrangling.